We won't have one. No test about cells. That's why I'm getting all these things in at once. I figured we'd do an open textbook kind of evaluation. Okay? So, no test on cells. I am starting the recording. Welcome to Science in the AM. I am subbing in for Mr. Eskra. I am Mr. Shindoka. Anyways. So, I think, had you guys already filled in the blanks on the types of matter? But you're left on classifying matter, is that correct? Where are you guys? Oh, just above here. Matter is a general term. Okay. Hey, look at this. The first thing up here. Matter is a general term. To use, I'll just pause. You guys can, okay. Matter is the general term used to describe all objects in the universe. Scientists define matter as anything that has mass or volume. Carissa, do you have this handout from the other day? Just use this. You don't need a blank sheet of paper. Bring the blank sheet of paper back up, and then just use your fill in the blank sheet, okay? Okay. So we're good with mass and volume, right? Anything that has mass or volume and or volume. Anyways, types of matter. Mass, and that's measured in kilograms in the metric system, or grams, is to measure the amount of substance in an object. Example, a brick has more mass than an equal-sized chunk of styrofoam. I think you guys know that, right? So, whereas volume, on the other hand, types of matter, is measured in liters, milliliters. You're familiar with those, especially with pop cans and stuff. 355 milliliters and stuff. 2 liter of pop, right? 4 liters of milk. Or centimeters cubed. Centimeter cubed, though, is actually the same size as a mil for solids. So, you ever hear of an engine, a motorcycle engine measured in cc's? You know what those stand for? Centimeter cubed. Anyways, I won't get into engines too much, but yeah. It's a measure of how much space something occupies, right? Volume than a baseball. A baseball, you said you're thinking basketball. Okay. Okay. It takes up more space. I think we all intuitively know that, right? I take up more space than a baby. I have more volume. Okay. I do. Okay, classifying matter. Let's talk about classifying matter real quickly. All matter is made up of different combinations of particles. Different combinations of particles give every type of matter different characteristics or properties. A property is a characteristic that describes a substance. Scientists classify matter as pure substances or mixtures, depending on how their particles are arranged. Okay? So you got a few things to jot down there. I'll pause the video. Pure substances are made up of only one kind of particle with a unique set of properties. They cannot be separated by any physical or chemical processes. Two types of pure substances, elements, compounds. An element is made up of the same type of element, like oxygen is O2, two O's connected together. Hydrogen, HH. Compounds are two or more different elements. Water, for example, H2O, hydrogen and oxygen combined in a ratio. I'm going to quickly skip out, though, to make a copy of this for... Okay, on this, do you notice that pure substances in this organizer chart here is either elements or compounds? Elements are one type of atom mixed, one type of molecule there. Okay, we've got mixtures, a combination of pure substances that do not combine chemically. There's two types of mixtures, homogeneous and heterogeneous. Homogeneous, the prefix homo means same. So homogeneous things are like solutions. You can't really tell, like a saltwater solution, if it isn't sinking to the bottom, that's a homogeneous solution. Salt is mixed in with the water. It's a mixture. But you can't tell the parts. An alloy. So if somebody has a gold ring, that's actually an alloy. It's not solid gold because solid gold's too soft. It's an actual sort of solid mixture. And it's actually a mixture, usually if it's yellowish, it's probably copper and gold mixed together in a solid solution, an alloy for more metals. Heterogeneous, hetero is the prefix meaning different. There's suspensions, emulsions, and mechanical mixtures. And I'm just going to see if there's some examples. We don't want to spoil all your questions. Yeah, that are coming up. Not yet. Okay. Okay. So there's the mixtures. Will lock themselves out, but we'll see. Are we good on this? Okay. Homogeneous mixtures. Yeah, this is why I held off on it. Solutions. Several items mixed together, but appears to be only one substance. Here's a bunch of things. Wine, coffee, air. Air is not just oxygen, it's nitrogen as well, and then a few other things small. Brass is a solid mixture. Steel is a mixture of iron and some other things. Natural gas that you burn, like in the furnaces and stuff like that, water heaters. Vinegar. Blood is a mixture, but it appears like it's one substance, but there's different parts inside. An alloy, two or more metals that are mixed and then cooled together. That's the steel and the brass. And I talked to you about gold jewelry, gold rings and stuff. Those would be. Gold even has a measurement to tell you how much gold is in the mixture if it's with copper. It could be other stuff. White gold isn't just mixed with other things other than copper. 24 karat gold would be 100%. That's not very practical because it's too soft. But probably heard of 10 karat or 12 karat gold or something like this. Think of it as 12 out of 24 possible parts or something like this, like 24 karat gold being pure. Now, you probably jotted those down. Is that correct? Looking around, okay. Heterogeneous mixtures coming up. Or, oh, not coming up. Alloy. Oh, here we go. 18 karat gold. Well, 18 out of 24 is 75% gold. Then there's copper, and then there's silver sometimes mixed in. I see. Brass, it actually gives you some examples. Sterling silver is really high in silver, 92.5% silver. Some copper for some mix in. Cast iron is 96 to 98% iron, and then a little bit of carbon to add strength to it, I guess. Bronze is mostly copper, and then some tin mixed in. Okay? I didn't know the percentages on it. Heterogeneous mixtures. Okay, there's some blanks for us. Substances from two different phases that don't fully mix together, liquid and solid. Can you think of something that's a liquid, and then if you let it sit, it's suspension, but if you let it sit, solid particles will settle out? Yes. You think on that, okay? A mud puddle, though, you ever notice sometimes, okay, what? What's that? What is it though? Oh, that's a cornstarch with water. Yeah, oobleck. Yes, yeah. Emulsions or colloids, substances where the same phase that don't mix well, a liquid and a liquid sometimes. Mayonnaise is often used as an example, right? But how about, oily salad dressings, vinegar and oil, like Greek salad dressing or Italian salad dressing? You shake it up, kind of mixes, but then 3 minutes later, it's separated, right? Doesn't mix well, okay? A mechanical mixture is easily separated. You can see all the components. A salad would be a good example of that. Just think of salad dressing. So salad, you can see the lettuce parts, the tomato parts, the cucumber parts or whatever, right? And you could sit and pick them apart if you want. That's a mechanical mixture, okay? You can see the components, the parts. Okay, we're good on that. You can see all the components or parts. 19. Classifying matter into categories, and this is your last fill in the blank thing, eh? Exactly. You have the flow chart, right? Matter, and then you got mixture or pure substance. You can just jot this down. Homogeneous, heterogeneous, or if it's a pure substance, element or compound. Then I have a few things for you. You guys can see that fairly well? I'll just make it a little bigger. Way better, right? You have a bit of ketchup. I want to vote. Okay, I'm going to hand this stuff out while you're still jotting it down. Homogeneous. Exciting. I'm going to talk you through the first few blanks of this handout, but not everyone is quite done. I think most of you are, but okay. Almost. Looking at the pencils moving. Okay, what I'm going to do is quickly just mention something. I know. Just hang on. I'll come back to that. There's a video, but you know what? I don't think I have access to it. Okay, I'm going to go back to this, and I'm going to go through the first few blanks with you guys. Okay. Now, I don't have this on here, so I'm going to just draw it on the board, but if you need this, you need a few more seconds on this? You need a few more seconds on it? Okay. You guys? Okay. So let's take a look at this while this is on the board. I'm going to just sort of jot down what's on here. We've got substance, mixture or pure. No, it's in your, this is, I'm going through this chart. So I'm just reproducing what you guys already have. Okay. Let's try the first one, ketchup. What you know of ketchup, is that a mixture or is it a pure? Mixture, okay. You're going to fill in mixture. Now, does it look homogeneous or can you actually see it separated?
You can see it separated.
Yeah, you ever notice watery stuff on the top of ketchup sometimes when it sits? You can see little, yeah. Yes? Oh, you don't? Okay, did you guys hand them back? Oh, because metal, yeah, was out here. Perfect, thank you. Okay. Homogeneous would be if it looks like it's just no parts to it, right? But we think that this is a heterogeneous mixture. You can see sort of lumpy stuff if you look carefully. Within heterogeneous, what do we think? Because it's not an alloy or solution. Is it a suspension, emulsion, or mechanical mixture? We might need to flip back and just see something, all right? So let's flip back and just see something here. Does it seem like it's two different phases? Or does it seem like it's two different liquids? I think it's phases because you could sort of see the little particles and stuff like this. Oh, there. So I'm going to go with, what is it called when it's two different phases? We're just on the page, guys. What's it called two different phases? Okay, we're going to flip back here. A suspension is when you have two different phases that, you know, solids and liquids sort of things. Oh, yeah, okay. That's what it is. We're going to go suspension. Okay? Let's go through with another one. Well, gold. Oh, good. Gold is something I brought up. Is that mixture or pure? That is pure gold. We're just saying it's not like jewelry gold. Okay. It's just one type of element, and they even put the symbol down here on this chart. So it is an element. It's one type of atom. And then that doesn't, an element doesn't break down any further, like into alloy or solution or whatever. It could be gold alloy if I said it was gold in jewelry, but we're assuming it's gold that's pure gold. If it was the mixture, like the jewelry type gold, 18 karat gold, 12 karat gold, then we'd say it's a mixture and it's an alloy. Okay, salsa. Okay, this one will be a little easier.
Wait, we don't want element and there's nothing for.
It isn't an alloy or a solution, no, no. Because an alloy is a mixture. If I said 18 karat gold, it wasn't 24 karat gold. You could interpret that gold one a little differently too, like you said. We're going to assume it's pure. Okay. Salsa is a mixture, as you can see in the charts. Homogeneous or heterogeneous? Homogeneous would be a mixture where you can't really tell that there's parts to it. Yeah, it's hetero. Okay. And we'll say suspension again, eh? You can see the solids. Oh, you know what? Yeah, you're right. Actually, mechanical is better. I'm going too fast. Because you can pick out the parts, but there are some things like, I could argue either one, but let's go with mechanical.
Salad, but most salad, you could say salad.
Yeah, I used salad as an example. You're interrupted, no? What was it about salad? Sorry, someone was saying?
I was saying salad, I meant salsa.
Yeah. Yeah. Oh, salsa. I'm just right. What am I thinking here? Mechanical. Yeah, my brain. That's multitasking. Okay. Okay, neon is an element. I'm just going to let you know that's pure. But I'm going to, okay, I'll go through it, neon and ammonia. Okay, neon is pure. It's an element and it doesn't break. But then I want to go through ammonia. You know that smell, that unique smell that Windex has? It's kind of like, ooh, don't breathe it in too deep. That's ammonia you're smelling. There's blue coloring added to it, but it's ammonia. Okay? Now, you'll notice right away there's an N, the element nitrogen and hydrogen mixed 3 to 1, right? Or 1 to 3, I guess. So this is, what would we say? Because when you see Windex, now Windex is ammonia mixed with some other stuff, but what are we going to say with that one? I'd say it's still a pure substance. But within that, is it all one type of element? No, it's nitrogens and hydrogens. So we're going to say it's a compound. And I'm not specifically talking about Windex where there's food color or coloring added and stuff like this. So nothing further on this. Sure. I'm going to let you go with brass, but if you remember, brass is a mixture. It's a solid mixture, but it's homogeneous. I'm going to go with brass, and I'll just do it here, and I'll let you go. I'll do one last one, then you can do the rest. Brass. It's copper and zinc mixed, so it's a mixture. It's not a compound, not chemically bonded, but it's a homogeneous compound, or a homogeneous mixture. And we call that an alloy, because it's a solid. Try the other ones out as best you can on this sheet, okay? By the way, I see oobleck, cornstarch and water is at the bottom of that side of the sheet. Okay?